Hello everyone, my name is Lakshman. Today I'm here to explain a presentation about the 2D geometric transformations in computer graphics and image processing. These are the table of contents in this presentation. The first one is Introduction to Computer Graphics. Next one is OpenGL Review. Third one is 2D transformations, and the fourth one is the conclusion. So basically, in the current real world, all the technologies are running on computer graphics and computer based technologies. So the introduction is computer graphics is a field of computer science that focuses on creating and manipulating visual content through computational techniques. So as I mentioned, AI and ML is the current trending course, and it is the current trending field for any job opportunities, and it is the main field for all the technologies based that are running in this generation and in this time. It is a versatile and dynamic area that intersects with numerous domains, including art, design, entertainment, and scientific visualization. The primary objective of computer graphics is to generate images and animations that are either realistic representations of the physical world or imaginative creations beyond the limitations of reality. So, in computer graphics, there are two types. The one is 2D graphics, and another one is 3D graphics. 2D graphics involves the creation and manipulation of images of a two-dimensional space, focusing on elements such as lines, shapes, and textures. 3D graphics involves creating and manipulating images in a three-dimensional space using concepts like modeling, rendering, and animation to produce lifelike scenes. So, OpenGL review overview. So, OpenGL is one of the computer-based platform in which we can create 2D and 3D transformations, and we can generate 2D and 3D based models using computer graphics. Open Graphics Library is the observation of OpenGL. Is a cross-language, language-independent, cross-platform, means it can run on any softwares. API for rendering 2D and 3D vector graphics. Vector graphics means use of polygons to represent image. OpenGL API is designed mostly in hardware. So basically, when we run the code using OpenGL, the below commands are the common commands used in the code. First one is glut init. It is used to initialize the variables used in the code. Glut init display mode is used to specify whether the display should be in a single window or double window. Window size specifies the number of pixels and the size of the window in which the code is running, and the graphics. Window position means it is either based on the position of the window. Glut create window is used to specify the title of the program and the computer graphics generated. Display function is used to generate the function of the graphics that is to be displayed by the function specified in the other part of code. And GL color 3F. In computer graphics, the commonly used three colors are RGB, red, green, and blue, and we can specify the colors as per the requirements in the form of numbers. And GL vertex 2i or 2v, 2f, 2f or 2iv. This is used to specify whether the data is in the format of integer, vector, float, or variable. So 2i means it is integer, 2v means variable, 2f means float, and 2iv means it is a vector. So let us come to the main concept of this presentation, that is 2D transformations. In 2D transformations, there are three types: translation, rotation, and scaling. So first one, translation means it is the moving of a particular point in the coordinate from one point to another. So translation means the moving of a point from one position to another position by specifying the distance between them. So as we can see in this first diagram, so this is the translation process that is going on in the computer graphics and in the system. So P in the brackets x comma y is the initial position, and we are moving it to the position x dash comma y dash, and the distance between them is specified by the user. So in this translation, we make use of two variables, that is tx and ty. Those are the translation vectors specifying the distance between the x and x dash and y dash in the two positions. So in the next diagram you can see the example of translation. So this is the original position of a polygon, and after the translation of it, by specifying the distance, this is the next position of it after the translation. So next is the scaling. So scaling is nothing but the enlargement or reducing the size of a diagram or figure using computer graphics. So let us take an example. If T1 is the original position specified in the first diagram, and if we want to enlarge it by 2 times, and in the first diagram original image, x1 y1 is the original position specifying the coordinates of the diagram, and if we want to increase it by 2 times, we have to scale it by 2 into x2 y2, and after that the enlarged image as you can see in the right side. So next one is the rotation. Rotation is nothing but the position, moving the position of a point or a figure from one point to another by specifying the angle between them. So rotation can be in 2 types. One is anti-clockwise direction and another one is the clockwise direction. So in the anti-clockwise, as you can see in this diagram, Q is the original position in the left side. After moving it in the anti-clockwise direction, by specifying the angle theta, it will move to the position Q dash. In the next diagram, you can see P is the original position, and P dash is the final position after specifying the angle in the clockwise direction. And in this both the diagrams, theta is the angle of rotation specifying the amount of rotation for the points. So this is the end of the presentation, guys. So hope you like the presentation about the 2D transformations using computer graphics. Thank you.